Last video, I discussed 15 questions of Grand Test 2. Remaining 15 questions I am discussing now. So here, n identical resistors. So let R be the resistance of each resistor. So when they are connected in series, R effective will be like this. Since all are identical, so R plus R plus R NR. If they are connected in parallel, 1 by R is 1 by R1. All are identical resistors. So R effective will be R by N. So now what he given is NR is X and R by N is Y. In the options only X, Y are there. N is not there. Let us eliminate N. From here, N is, so this is R square is XY. Here R is root of XY. So third option is correct. Here in second question, a circular portion of diameter R is cut from a uniform circular disk of mass M. So here M is mass of total disk. So here disk is not like a ring. Mass is spread out throughout its area. Mass is measured in terms of area. So here bigger one, radius is R. Mass is measured in terms of area. The part which is cut from the disk whose diameter is R, its radius is R by 2. Its area will be, so that is pi R by 2 whole square, because its radius becomes R by 2, pi R square by 4. So total disk mass is M. The portion which is cut, its mass is, I will write M by 4. The part remaining, this one, its mass will be 3M by 4. Now, the moment of inertia of the remaining portion of the disk about an axis passing through the center. Here it is passing through the center about this axis. We have to find moment of inertia of the remaining disk. So I total about this axis is equal to about an axis which passes through the center. So here the portion which is cut off, the portion which is remaining. What we have to find out is moment of inertia of remaining portion, which is I total minus the portion which moment of inertia of the portion which is cut. So total moment of inertia is obvious, direct formula to find moment of inertia of the portion which is cut. So it has a center at this point. So about this axis, let us say it is xy. Moment of inertia of portion which is cut about xy axis is m dash r, its radius is r by 2, r by 2 whole square, disk formula, which is m dash r square by 8. But that m dash here is m1 for us. So let us not confuse you. I'll write same symbol m1. Here m1 r square. m1 is m by 4, which is mr square by 30, because m1 is m by 2. Now here, but we have to find its moment of inertia about tangent. Here it is, this is a tangent. About this axis we have to find out. Let us say AB. So moment of inertia about AB will be about this, it is mr square by 32. So it's a parallel axis theorem. I equal to IC plus mr square. Here m is 3, it's a m here is m by 4. I'll write m1. R is r by 2 whole square. mr square by 32 plus mr square by 16. So once after simplification, we get 2mr square, which is 3mr square by 12, 32. So now the moment of inertia of the remaining portion total here is this. So removed part moment of inertia is this. So 16 mr square minus 3 mr square, 13 mr square by 32. Third option. Here, an air bubble of radius r rises from the bottom to the surface of a lake. So this is our lake. Here is a bubble. So here completely filled with water. So atmospheric temperature is fixed. So here pressure acts on this part, bubble will be till here atmospheric pressure. So let us say level of the water is at a height, level of the water is H. So at this point P, at P, pressure is atmospheric pressure plus pressure due to water. That is P naught plus HdG. So when it comes to the surface, its radius, he told that radius is increased. So here radius is, here its radius is r. When it comes to the surface, its radius increases. Originally, it is a spherical shape. Volume is 4 by 3 pi r cube. At this point P, at Q, pressure is only P naught. Volume is 4/3 pi in place of r, 5 r by 4 whole cube. 125 by 64 r cube. So at constant temperature, So PV here is N constant, obviously RTR constant. P1 V1 is P2 V2. So P naught plus HDG. Here V1 is 4/3 pi R cube. P2 is only P naught. So volume is 125 by 64 R cube. Get cancel. 4 pi by 3 get cancel. So here it is P naught plus HDG is 125 P naught by 64. So here further simplification, 125 P naught by 64 minus P naught HDG. This pressure he told 10 meters height of water column. Water density of water 1000 kg per meter cube, which is 10 power 5. P naught into 64 is equal to 10 power 5. So here pressure is 10 power, this is nothing but 125 minus 64 is, that is 61 by 64, which is equal to 10 power 5. So P naught will be 10 power 5 into 64 by 61. So he given atmospheric pressure is equal to 10 meters. Sorry, this is atmospheric pressure. So this is not HDG formula. This is only atmospheric pressure. P naught is this. So what we have to find out is to what level it rises. Which is HDG. Here it is. H here is, we don't know, density of water into 10. G is 10. Here P naught, we already know that 10 power 5 into 61 by 64. H into 10 power 4. H will be 610 by 64. It is roughly nearest 10, less than 10, 9.53 meters. Here, heater boils certain quantity of water in time T1. Another heater boils same quantity of water in T2. So heat required to boil, so m grams of water, so let us say certain quantity means ms delta T. So to boil, boiling point of water is this. So mass is fixed, specific heat of water is fixed. So for boiling temperature is fixed. So that heater here, that water gets heated up with the help of a coil whose resistance is R, that is connected to a battery of potential difference V, and its resistance is R1. So heat produced is V square R1 by using one coil to boil water. Time required is T1 seconds. So another coil by using same battery, but resistance is different. So here heat produced will not change. Potential difference is not changing. Resistance changes, time changes. So here from here R1 is V square T1 by H. Here R2 is V square T2 by H. When both the coils are connected to the same battery, R1 and R2 are their resistance. Time taken to boil water, this will not change, H will not change. V square R by T. Since resistors are connected in series, R is R1 plus R2. So now here R1 is R is equal to R1 plus R2. R here is V square T by H. R1 is R2 is V square T2 by H. Everywhere V square by H is there, cancel out. So the time taken to boil same quantity of water is T1 plus T2. Here, 4 charges equal to minus Q are placed at 4 corners of a square, and the charge Q is at the center. System is in equilibrium, then value of K. Generally, what we do is system is in equilibrium means net force on Q will be 0. Right. So here, suppose on this positive charge, this negative charge will attract with some force. This negative charge will attract with the same force. Net force get cancelled out. Here, this negative charge will attract this positive. This positive, net force is 0. So we cannot establish any relation. System is in equilibrium means even the charge at minus Q, at this point also net force is 0. So force at C is 0. That is here one force. Here these two forces, here both charges are negative, they get repelled. So this is F1. So F1 is force on charge minus Q present at C due to charge present at D. So that is equal to F1. Here, let us take side of a square is D. F1 will be K Q by d square, right? Coulomb's law. And similarly, F2 direction will be minus q, they repel. So this charge get repelled by charge present at B. That is also kq by d square. Second. Here, force on minus q due to this, both are same charges. F3 will be kq square by, so it is d, it will be root 2d, that is root 2d whole square, kq square by 2d square, it is third. Now force on fourth one, F4 will be, here direction will be, this get repelled due to this in this direction. Now fourth force between minus q and q. So this q will attract minus q with a force k. Here total is root 2d. This distance will be root 2d by 2, which is d by root 2. So kq square by d by root 2 whole square, which is 2kq square by d square. Totally 4 forces are acting on this. So the net force here, net force is F1 plus F2 plus F3 plus F4. So F1, F2 are equal in magnitude. Once they are equal in magnitude, resultant of these two force will be along the diagonal. So resultant of these two will be F1 square plus F2 square, since they are perpendicular. Even F3 also act in the same direction. F4, this only will act in different direction because that is attracted. So here this will be fourth force, F4 will act like this. This Q will attract minus Q towards it. So that is, I will write minus F4 is 0. So F1 square plus F2 square, both are equal in magnitude. So F1 is F2 numerically, that is F square plus F square. F3 is KQ square by 2D square. It is root 2F. The F4 will be, one is, sorry, here Q, 2KQ by D square is equal to 0. Plus KQ square by 2D square is 2KQQ by D square. So here F is nothing but KQ square by D square plus KQ square by 2D square is, so D square everywhere get cancelled. So KQ also everywhere. Q by 2 will be 2Q. So Q here is 2 root 2 plus 1 Q by 4. Right. The value of Q is this much. So in next problem, critical angle we use when ray move from denser to rarer for one particular angle. So it gets reflected ray makes an angle 90 degrees with the normal. So that is mu sin C is equal to 1 is refractive index of air. So this is air, here is denser medium whose refractive index is mu. So sin C here is 1 by mu. So here about polarizing angle, 1 minute. So polarizing angle means unpolarized light when it is incident on non-metallic surface. So it gets reflected and finally it get polarized. This is incident ray. It is reflected ray and it is refracted ray. So for one particular angle, maximum polarization occurs. That angle is IP polarization angle. When this happens means reflected and refracted ray are at right angles. So this is angle of refraction. The angle of incident and angle of reflection are same. So IP plus R is plus 90 is equal to 180. IP plus R is equal to, so mu P here, which is IP. IP plus R is 90. IP is 90 minus R. Again, applying Snell's law, mu sin IP is equal to, so 1 into sin R, which is R is 90 minus IP. So mu sin IP is so tan IP will be 1 by mu. So that 1 by mu is sin C. So critical angle he given it as, sorry, here it is mu sin, here 1 into sin IP. Mu sin R. So here it is tan IP will be, which is mu, which is equal to 1 by sin C. So critical angle he given 30, sin 30 is half, which is 2. So polarizing angle is tan inverse 2. Here parallel plate capacitor of capacitance 100 picofarads. Pico is 10 power minus 12 farad. Is to be constructed by using paper sheet of thickness for finding capacitance of capacitor. we use a formula A epsilon naught by D. Here we have a paper sheets of thickness 1 mm. The D is 10 power minus 3 meters. If the dielectric constant is dielectric constant, like here, once dielectric is placed here, so the dielectric constant is K, then capacitance increases, that is C dash equal to K A epsilon naught by D. So here finally he is asking metal foils. How many metal foils are there? This is one metal foil. This is other metal foil. So in between paper is placed whose thickness is 1 mm. So to prepare capacitor, we require two metal foils to prepare one capacitor. So let us see how many capacitors are required to prepare a capacitor of capacitance 100 picofarads. So here one capacitor capacitance area here is it is circular here it is circular metal foils. Pi r square will be area epsilon naught by d here is 10 power minus 3. So we know that 1 by 4 pi epsilon naught is 9 into 10 power 9. So dielectric constant is 4. It is 4 pi epsilon naught r square by 10. So this its value 4 pi epsilon naught is 1 by 9 into 10 power 9, 10 power minus 3. R square 1 10 power 6. This is capacitance of one capacitor. So to prepare parallel plate capacitor of capacitance 100 picofarads, such capacitors has to be connected in parallel. If capacitors are connected in parallel, effective capacitance is this. So how many means if n capacitors are connected in parallel of equal capacitance, effective capacitance is this. So here C dash will be R square by 9 into 10 power 6. Here diameter is 2 centimeter, radius will be 1 by 10 centimeter, it is 10 power minus 2. That is n into 10 power minus 4, 10 power minus 6. So here n into 10 power minus 10 by 9. Which is equal to 100 picofarads. It's 10 power minus 10. That means how many such capacitors are required? 9 capacitors. Each capacitor has 2 metal foils. So number of metal foils required is 9 into 2, which is 18. Here, ammeter reads up to 1 ampere. It has some internal resistance, 0.81 ohms. So to increase its range, instead of measuring 1 ampere, to measure 10 amperes, so directly so sensitive it cannot bear more than 1 ampere. So one resistance, small resistance, which is connected in parallel. So here, if resistance is small, more current will flow through this, less current will flow through this. So here, maximum current flows through ammeter is 1 ampere. To measure more current, which is 10 amperes current, remaining current will flow through this parallel resistor, which is called shunt. So potential difference, since they are connected in parallel, potential difference across ammeter is equal to potential difference across resistance. So Ig into ammeter resistance 0.81, I minus Ig into that resistance. Here Ig is 1, maximum current through ammeter. Here I is the current which we have to measure, 10 amperes, 10 minus 1 into R. So R will be 0.81 by 9, that is 0.09 ohms. That has to be connected in parallel. Increase in length of a wire. Given percentage, that is percentage increase is 0.025. Poisson ratio sigma is equal to lateral strain by longitudinal strain. Due to stress, length increases. Originally wire like this, length increases, its diameter decreases. So sigma is equal to delta L by L. What he is asking, percentage decrease in diameter, D into 100 minus sigma delta L by L into 100. So Poisson ratio he given, this is 0.025. So it is minus 0.01. So percentage decrease will be 0.0. There are two long parallel wires. Are separated by a distance r having equal current flowing in each. Separated by a distance r. The magnetic field, one exert a force upon other. That force exerted by magnetic field per unit length is mu naught I1 I2 by 2 pi r. Now he says distance is increased. Distance is increased to r and current in each wire reduces to I by 2. Now force will be new force mu naught here. So in both wires, same current is flowing. I1 is I, I2 is I. So it will be mu naught I square by 2 pi r. Here it is I by 2 whole square by 2 pi. The distance is increased. So mu naught I square by 8 times 2 pi r. That is by 8. That is new force here per unit length. So value of K is 8. So wire is of shape, cylindrical shape. So density is equal to mass per unit volume. Volume of a wire is volume of a cylinder pi r square L. So density will be, so here maximum percentage error in diameter, in density is delta m by m. Here r square is there. Forget about the constants. 2 delta r by r plus delta L by L. Percentage error he is asking. Delta M, change in mass by 0.3. Delta R, 0.005 by 0.5 plus delta L, 0.0006 by 6 into 100. So if you multiply by 100, it's 1. So here it's 0.5 by 0.5, 1, 6 by 6, that is how much? 4%. Next, an ideal solenoid of cross-sectional area is 10 power minus 4 meter square. So here N is number of turns per unit length, that is per meter 500. So magnetic field inside solenoid is equal to mu naught Ni. Here I1 current flows through it. So once here current is flowing in this direction, magnetic field lines will be generated. So here, if you place another coil, as you change the current, there is change in flux lines. EMF is induced in the coil. So he is asking EMF developed in the second coil. Here, second coil is another solenoid having same cross sectional area. So here, because of current through first solenoid, here current changes, flux changes in the second solenoid. So what is that flux will be calculated. Here flux is nothing but B1. So that B1 is due to the magnetic field due to this current. Since both are having, so wrapped closely around it, both areas are same. So B1 here is mu naught N1. Here N1 stands for number of turns per unit length in the first solenoid. Right. Now, the second solenoid also contains 100 turns. So total flux through 100 turns will be mu naught N1I into N2 into area. EMF induced is d5 by dt, that is mu naught N1 N2 IA by time taken is 3.4 milliseconds. Mu naught is 4 pi into 10 power minus 7. N1 is 500, N2 is 100. Current is 2 amperes. And area of cross section is 10 power minus 4 by pi into 10 power. Y get cancel out. So 10 power minus 3, 10 power minus 1 times 4 into here 2 zeros, it is 10 power minus 3. 20 into 2, 40 into 10 power minus 4. Which is nothing but 4 into 10 power minus 3 volts. This is the EMF induced in the second coil. Here is closed argon pipe. So in fundamental mode of vibration, distance between antinode and node is lambda by 4. So this is lambda is 4L. Since it is not mentioned any mode, so I'm taking fundamental mode. So in another case, it is open pipe. So lambda by 4 plus lambda by 4. Total length is lambda by 2. So here, number of beats will be N1 minus N2. So here V is N lambda. So in one case, V by lambda, that is V by 2L, N2 will be V by 4L. If length of each of them is twice, what is the how do we calculate number of beats? V by 4L minus V by since length is doubled. Here it is 4L 2 minus V. It becomes V by 7. That means earlier 4 bits, now number of bit becomes V by 2L, 8L means half of that. Of different focal lengths are placed 70 centimeters apart facing each other. So let us take the concave mirror. So inside is reflecting surface, it is silvered. And another is convex mirror. So where the inner part is silvered. This is reflecting surface. So here difference between these two is P dash is 70 centimeters. And this one is concave mirror. This is convex mirror. Its focal length 15 centimeter. Its focal length 10 centimeters. A 2 centimeter tall object is placed perpendicular to the common axis at 20 centimeter from the concave mirror. That is in between focal length and radius of curvature. So ray from this object gets reflected and passes through the focus. And here another ray which get reflected somewhere, image is formed. So this image with respect to one mirror acts as a object for the second mirror. So let us see where image is formed. So if you consider mirror formulae, object rays are traveling towards right, distances will be measured from pole. Object is here, object will be negative, that is object distance. U here is minus 20. Focal length also towards left, that is minus 50. So 1 by V is equal to 1 by F minus 15 plus, here it is 60. 1 by V is minus 1 by 60. V here is minus 60. That means image is formed at a distance of 60 centimeter from pole P. So here total is 70, it is 60. So with respect to convex mirror, object is at 10 centimeter. So here it is a parallel ray incident on it that can get reflected. So here another ray you take which is incident on at this point. This extended rays forms an image somewhere here. So now with respect to convex mirror, again same mirror formula I am writing. So here, so here light rays are traveling towards left. Object distance will be measured towards right. U will be, that is at -10. Focal length towards the direction of right, in which direction rays travels towards left. So focal length is positive. So 1 by V will be 1 by F minus 1 by U. So F here is 10 minus 1 by 10. So 2 by 10. So that is V equal to 5. So that's what he is asking. How far from the final image is formed by two reflections. Here one reflection, here second reflection. After second reflection, this image distance will be at 5 centimeter from the convex mirror. So this type of problems, the Newton's law of cooling. So rate of fall of temperature is directly proportional to difference of the temperature at that time and surroundings. So d theta by dt is d theta here. Change in theta. So that is 75 minus 65. Time taken is 2. Here theta consistently changes from 75 to 65. So what we do is we take average surrounding temperature minus K, 75 plus 65, 140 by 2 minus K into 40. K here is minus 1 by 8. 55 minus 45 by time taken. So here theta average surrounding temperature. So here it is 100 by 2 is 20 K. So 10 by T is equal to 20. K value is minus 1 by 8, which is so 10T. Phi T is equal to T here is